Okay, we are live. Welcome, Whenmill, who is here on a voice call.
Hello.
I would like us to go through the book called Welcome to Python for You and Me. I just found this book and it looks pretty promising. It says this is a simple book to learn Python programming language. It is for the programmers who are new to Python. If you are new to the command line in Linux, you can read lim. I'm going to skip that for now. Contents installation. I'll assume you've already installed Python.
Yes.
So let's go to the beginning. Let's look at our first code, hello world. Because Python is an interpreted language, you can write the code into the Python interpreter directly, or you can write the code in a file and then run the file. In this topic, we will first write the code using the interpreter after starting Python in the command prompt shell or terminal. If you are new to the Linux command line, you can read about Linux commands in this book. Read the docs, LIM. We'll skip that. The following is from Fedora 34 machine running Python 3.10. I'm going to pull up my iCharm. And maybe I want to... I don't have anything embarrassing in the background, do I? What do I have there?
Not that I can see.
It's just some code. It's just some code. That's fine. Speaking of, you can see, how well can you see?
It looks fine to me.
Okay, if it looks good, if it looks fine to you, then it's probably going to be pretty good for viewers as well. Because of the way I installed Python, I have to say conda install base before I say Python. But then when I enter Python, then I'm inside the Python interpreter. Or the Python command prompt, sorry. I'm inside of the Python command prompt. And we'll now continue with the book. It says using the Python interpreter. In our first code, we are going to print hello world using the interpreter. To generate the output, type the following. I will type that, and if you'd like to, you could type along on your machine. Or you could just watch me, up to you. Which way do you think you want to do it?
I am gonna follow along.
Great.
I'm all caught up.
You're all caught up, and it told you hello world?
Yes.
Perfect. So we can move on. It says, as a serious programmer, you might want to write the above code into a source file. Use any text editor you like to create the file helloworld.py. I used VI. You can even use GUI-based tools like Kate or Gedit. In the latter part of the book, I will help you to use a few different editors.
I'm using Pycharm because I'm used to it.
That'll work. My computer is running low on disk space. I'll deal with that later. I'm going to use Vim because I'm familiar with that. I have to exit. You'll have to exit out of... Oh, oops. I will say vim hello.py, and it looks like it's having me give a comment that, so this might look somewhat mysterious, but I think it's to let a shell know Oh, this is weird.
What's happening?
It's saying to run it as a shell script. And then, I guess I'll try it this way. Print hello world. chmod +x hello world.py. Oops. Have to write this again. Or we could jump to a different book that I'm more familiar with.
Okay, that works for me.
Because this book is doing some odd things that I'm not as familiar with. Let's do Think Python Alan Downey. Think Python 2 edition, Green Tea Press. Were you around when we started looking at this on the stream? Well, I'll probably read the introduction for the viewers, whether you have or not. So, Think Python, How to Think Like a Computer Scientist. Preface. The strange history of this book. In January 1999, I was preparing to teach an introductory programming class in Java. I had taught it 3 times and I was getting frustrated. The failure rate in the class was too high, and even for students who succeeded, the overall level of achievement was too low. One of the problems I saw was the books. They were too big with too much unnecessary detail about Java and not enough high-level guidance about how to program. And they all suffered from the trapdoor effect. They would start out easy, proceed gradually, and somewhere around chapter 5 the bottom would fall out. The students would get too much new material, too fast, and I would spend the rest of the semester picking up the pieces. 2 weeks before the first day of classes, I decided to write my own book. My goals were: keep it short. It is better for students to read 10 pages than not read 50 pages. Be careful with vocabulary. I tried to minimize jargon and define each term at first use. Build gradually. To avoid trapdoors, I took the most difficult topics and split them into a series of small steps. Focus on the programming, not the programming language. I included the minimum useful subset of Java and left out the rest. I needed a title, so on a whim I chose How to Think Like a Computer Scientist. My first version was rough, but it worked. Students did the reading and they understood enough that I could spend class time on the hard topics, the interesting topics, and, most important, letting the students practice. I released the book under the GNU Free Documentation License, which allows users to modify, copy, and distribute the book. What happened next is the cool part. Jeff Elkner, a high school teacher in Virginia, adopted my book and translated it into Python. He sent me a copy of his translation, and I had the unusual experience of learning Python by reading my own book. As Green Tea Press, I published the first Python version in 2001. In 2003, I started teaching at Olin College, and I got to teach Python for the first time. The contrast with Java was striking. Students struggled less, learned more, worked on more interesting projects, and generally had a lot more fun. Since then, I've continued to develop the book, correcting errors, improving some of the examples, and adding material, especially exercises. The result is this book, now with less grandiose title, Think Python. Some of the changes are: I added a section about debugging at the end of each chapter. These sections prevent general techniques for finding and avoiding bugs and warnings about Python pitfalls. I added more exercises ranging from short tests of understanding to a few substantial projects. Most exercises include a link to my solution. It's interesting he says to my solution and not to the solution, which hints at the possibility that there may be more than one correct solution. Anyway, I added a series of case studies, longer examples with exercises, solutions, and discussions. I expanded the discussion of program development plans and basic design patterns. I added appendices about debugging and analysis of algorithms. The second edition of Think Python has these new features. The book and all supporting code have been updated to Python 3. I added a few sections and more details on the web to help beginners get started running Python in a browser, so you don't have to deal with installing Python until you want to. For chapter 4.1, I switched to my own Turtle graphics package called SwampPy to a more standard Python module, Turtle, which is easier to install and more powerful. I added a new chapter called The Goodies, which introduces some Python features that are not strictly necessary but sometimes handy. I hope you enjoy working with this book and that it helps you learn to program and think like a computer scientist, at least a little bit. Alan B. Downey, Olin College. So what do you think of that so far? Does that sound promising?
Oh yeah, I mean, it sounds like he sure knows what he's doing at least.
Yeah, I think so. All right, we'll go right on with it. Chapter 1, The Way of the Program. The goal of this book is to teach you to think like a computer scientist. This way of thinking... Sorry, this is going to bother me if I don't move things around. That's better. This way of thinking combines some of the best features of mathematics, engineering, and natural science. Like mathematics, computer scientists use formal languages to denote ideas, specifically computations. Like engineers, they design things, assembling components into systems and evaluating trade-offs among alternatives. Like scientists, they observe the behavior of complex systems, form hypotheses, and test predictions. The single most important skill for a computer scientist is problem solving. Problem solving means the ability to formulate problems, think creatively about solutions, and express a solution clearly and accurately. As it turns out, the process of learning to program is an excellent opportunity to practice problem-solving skills. That's why this chapter is called The Way of the Program. On one level, you will be learning to program, a useful skill by itself. On another level, you will use programming as a means to an end. As we go along, that end will become clearer. I'd like to take a moment and take a step back and ask you, Whenmill, what might some of the he said means to an end. What might some of the ends be for you?
Well, as we've talked before, I'm trying to automate not just my job, my entire team's job, which sounds evil when you put it that way.
It does a little bit.
But yeah, no, that's the means to my end, or that's my end, and Python is the means. But ultimately, like, I remember the first, I don't think I've ever told you about this. The first bit of dabbling I ever did in programming was with C#. I was trying to make a fake virus to prank my brother. And so it was basically just, a small window that said, "Congratulations, you have a virus." And every time you went to press X to close it, instead of closing, it would just reopen it in an infinite loop until you turned off your computer.
That is evil.
Yeah, and he was pissed. But it was definitely a lot of fun.
Wow. There's another quote in another book about how we need to keep programming fun, and it's interesting that that's where you started, is with it being fun in some way.
Yeah, no doubt. That's yeah. I don't think that I would be interested in programming if there wasn't this level of that level of fun that's involved with it. It's not just practical.
For me, the feeling is really satisfying to understand and build something, which is kind of related to fun, I think.
Yeah, I mean it is definitely your version of fun, which is what matters.
There you go. That's good. Okay, 1.1. What is a program? A program is a sequence of instructions that specifies how to perform a computation. The computation might be something mathematical, such as solving a system of equations or finding the roots of a polynomial, but it can also be a symbolic computation, such as searching and replacing text in a document, or something graphical, like processing an image or playing a video. The details look different in different languages, but a few basic instructions appear in just about every language. Input: get data from the keyboard, a file, the network, or some other device. Output: display the data on the screen, save it in a file, send it over the network, etc. Math: perform basic mathematical operations like addition and multiplication. Conditional execution: check for certain conditions and run the appropriate code. Repetition: perform some action repeatedly, usually with some variation. Just earlier today, I was watching a stream by Big Data Build, or Build Data Big, or something like that, who works at CockroachDB, and was talking about how when you write things on the query side of their database, that program is going to get run potentially millions of times, once for each row. So any efficiency you can increase in that makes a big difference end to end when you're running things in the real world. So that just made me think of repetition. Just made me think of that. So I thought I'd mention that from earlier this afternoon. Anyway, it goes on. Believe it or not, that's pretty much all there is to it. Every program you've ever used, no matter how complicated, is made up of instructions that look pretty much like these. So you can think of programming as the process of breaking a large, complex task into smaller and smaller subtasks until the subtasks are simple enough to be performed with one of these basic operations. Sorry, one of these basic instructions. 1.2, running Python. One of the challenges of getting started with Python is that you might have to install Python and related software on your computer. If you're familiar with your operating system, and especially if you're comfortable with the command line interface, you will have no trouble installing Python. But for beginners, it can be painful to learn about system administration and programming at the same time. To avoid that problem, I recommend that you start out running Python in a browser. Later, when you are comfortable with Python, I'll make suggestions for installing Python on your computer. There are a number of web pages you can use to run Python. If you already have a favorite, go ahead and use it. Otherwise, I recommend Python Anywhere. I provide detailed instructions for getting started at tinyurl.com/thinkpython2e. I'm going to go ahead and use Python on my machine since I already have it here.
Yeah.
And you may as well do the same since you do have Python.
Yeah, you know what? I've actually run into problems of having multiple versions of Python on my PC. That's actually a big reason why I cleared out my drives, is because
Oh, wow.
I had several versions of 2.9, or not 2.9. Oh no! I had some. No, it was 2.7, 3.9, and then 3.10, all saved in different places. And it was just, anytime I tried to run pip, it was impossible to figure out which one I was trying to use. I mean, it wasn't impossible, I just don't know it well enough.
Yeah, it can get complicated. That's why I'm using, that's when I did conda activate base. That's a Python environment manager. And it helps me get around the fact that I also have multiple Python installations bouncing around on my computer. And I'm
gonna have to learn that.
Yeah, we can maybe look into that later, but let's continue on this. There are two versions of Python called Python 2 and Python 3. They are very similar, so if you learn one, it is easy to switch to the other. In fact, there are only a few differences you will encounter as a beginner. This book is written for Python 3, but I include some notes about Python 2. The Python interpreter is a program that reads and executes Python code. Depending on your environment, you might start the interpreter by clicking on an icon or by typing Python on a command line. When it starts, you should see output like this. So there's that output. And sure enough, I see some similar output. I guess I'm at 3.8.5, but I think that'll be just fine for these purposes. The first three lines contain information about the interpreter and the operating system it's running on. So it might be different for you, but you should check that the version number, which is 3.4.0 in this example, begins with 3, which indicates that you are running Python 3. If it begins with 2, you are running, you guessed it, Python 2. The last line is a prompt that indicates that the interpreter is ready for you to enter code. If you type a line of code and hit enter, the interpreter displays the result. So let's try it, 1 + 1, 2, and go ahead and try that on yours as well.
Yes.
Good. Now you're ready to get started. From here on, I assume that you know how to start the Python interpreter and run code.
Yeah.
The first program. Traditionally, the first program you write in a new language is called Hello World, because all it does is display the words Hello World. In Python, this looks like print, parenthesis, quote, hello, comma, world, exclamation point, end parenthesis. This is an example of a print statement, although it doesn't actually print anything on paper. It displays the result on the screen. In this case, the result is words, hello world. The quotation marks in the program mark the beginning and end of the text to be displayed. They don't appear in the result. The parentheses indicate that print is a function. We'll get into functions in Chapter 3. In Python 2, the statement is slightly different. It is not a function, so it doesn't use parentheses. Print space hello world. The distinction will make more sense soon, but that's enough to get started. 1.4 Arithmetic Operators. After hello world, the next step is arithmetic. Python provides operators, which are special symbols that represent computations like addition and multiplication. The operators plus, minus, and asterisk perform addition, subtraction, and multiplication, as in the following examples. 40 plus 2, 42. 43 minus 1, 42. 6 times 7, if I can type, 42. The operator slash performs division. 84 divided 2, 42.0. You might wonder why the result is 42.0 instead of 42. I'll explain in the next section. Finally, the star operator performs exponentiation. That is, it raises a number to a power. 6 star star 2 plus 6. I guess we needed the plus 6 there to get us to 42. In some other languages, caret is used for exponentiation, but in Python it is a bitwise operator called XOR. If you are not familiar with bitwise operators, the result will surprise you. 6 caret 2 4. I won't cover bitwise operators in this book, but you can read about them at python.org MOIN bitwise operators. We'll just bravely skip past the bitwise operators part. Any questions on the above?
Nope.
Yep. 1.5 Values and types. A value is one of the basic things a program works with, like a letter or a number. Some of the values we've seen so far are 2, 42.0, and hello world. These values belong to different types. 2 is an integer, 42.0 is a floating point number, hello world is a string, so called because the letters it contains are strung together. If you're not sure what type of value it has, the interpreter can tell you. Type of 2, int. Type of 42.0, class float. Type of hello, comma, world. It maybe isn't so important that I get every bit of punctuation correct, but oh well. Class string, str. In these results, the word class is used in the sense of a category. A type is a category of values. Not surprisingly, integers belong to the type int, strings belong to str, and floating point numbers belong to float. What about values like quote 2 and quote 42? They look like numbers, but they are in fact quotation marks like strings. Type of 2, class string. Type of quote 42.0, class string. They're strings. When you type a large number, you might be tempted to use commas between groups of digits, as in 1, 000, 000 dot. This is not a legal integer in Python, but it is legal. 1, 000, 000. Results in parenthesis 1, 0, 0. That's not what we expected at all. Python interprets 1, 0s, as a comma-separated sequence of integers. We'll learn more about this kind of sequence later. 1.6 Formal and natural languages. Natural languages are the languages people speak, such as English, Spanish, and French. They are not designed by people, although people try to impose some order on them. They evolved naturally. Formal languages are languages that are designed by people for specific applications. For example, the notation that mathematicians use is formal language that is particularly good at denoting relationships among numbers and symbols. Chemists use a formal language to represent the chemical structure of molecules. And most importantly, programming languages are formal languages that have been designed to express computations. Formal languages tend to have strict syntax rules that govern the structure of statements. For example, in mathematics, the statement 3 plus 3 equals 6 has correct syntax, but 3 plus equal 3 $6 does not. In chemistry, H2O is a syntactically correct formula, but 2ZZ is not. Syntax comes in two flavors pertaining to tokens and structure. Tokens are the basic elements of the language, such as words, numbers, and chemical elements. One of the problems with 3 plus equal 3 $6 is that $sign is not a legal token in mathematics, at least as far as I know. Similarly, 2ZZ is not legal because there is no element with the abbreviation ZZ. The second type of syntax rule pertains to the way tokens are combined. The equation 3 plus divide 3 is illegal because even though plus and divide are legal tokens, you can't have one right after the other. Similarly, in a chemical formula, the subscript comes after the element name, not before. This is a well-structured English sentence with invalid tokens in it. This sentence, all valid tokens has, but invalid structure with. It's fascinating how the first one is so much easier to read than the second. When you read a sentence in English or a statement in a formal language, you have to figure out the structure, although in a natural language you do this subconsciously. This process is called parsing. Although formal and natural languages have some features in common, tokens, structure, and syntax, there are some differences. Ambiguity. Natural languages are full of ambiguity, which people deal with by using contextual clues and other information. Formal languages are designed to be nearly or completely unambiguous, which means that any statement has exactly one meaning, regardless of context. Redundancy. In order to make up for ambiguity and reduce misunderstandings, natural languages employ lots of redundancy. As a result, they are often verbose. Formal languages are less redundant and more concise. Literalness. Natural languages are full of idiom and metaphor. If I say the penny dropped, there is probably no penny and nothing dropping. This idiom means that someone understood something after a period of confusion. Formal languages mean exactly what they say. Because we all grow up speaking natural languages, it is sometimes hard to adjust to formal languages. The difference between formal and natural languages is like the difference between poetry and prose, but more so. Poetry. Words are used for their sounds as well as their meaning, and the whole poem together creates an effect or emotional response. Ambiguity is not only common, but often deliberate. Prose. The literal meaning of words is more important, and the structure contributes more meaning. Prose is more amenable to analysis than poetry, but still often ambiguous. Programs. The meaning of a computer program is unambiguous and literal, and can be understood entirely by analysis of the tokens and structure. Formal languages are more dense than natural languages, so it takes longer to read them. Also, the structure is important, so it's not always best to read from top to bottom, left to right. Instead, learn to parse the program in your head, identifying the tokens and interpreting the structure. Finally, the details matter. Small errors in spelling and punctuation, which you can get away with in natural languages, can make a big difference in a formal language. Any thoughts on what we've got through so far?
No thoughts. I don't know. I'm ready to get like, I don't know. I'm ready to jump into things. I want to start writing viruses.
We're almost there.
Let's do it. Let's become Hacker Man.
1.7 Debugging. Programmers make mistakes. For whimsical reasons, programming errors are called bugs, and the process of tracking them down is called debugging. Programming, and especially debugging, sometimes brings out strong emotions. If you are struggling with a difficult bug, you might feel angry, despondent, or embarrassed. There is evidence that people naturally respond to computers as if they were people. When they work well, we think of them as teammates, and when they're obstinate or rude, we respond to them in the same way we respond to rude, obstinate people. Reeves and Nass, The Media Equation, How People Treat Computers, Television, and the New Media Like Real People and Places. Preparing for these reactions might help you deal with them. One approach is to think of the computer as an employee with certain strengths like speed and precision, and particularly weaknesses like lack of empathy and inability to grasp the big picture. Your job is to be a good manager, find ways to take advantage of the strengths and mitigate the weaknesses, and find ways to use your emotions to engage with the problem without letting your reactions interfere with your ability to work effectively. Learning to debug can be frustrating, but it is a valuable skill that is useful for many activities beyond programming. At the end of each chapter, there's a section like this with my suggestions for debugging, so if they help. And I'll gloss through the glossary, because what's a glossary for?
Oh, that's funny. I realized what you did there.
Yeah, see what I did there? Exercises. It is a good idea to read this book in front of a computer so you can try out the examples as you go. Whenever you are experimenting with a new feature, you should try to make mistakes. For example, in the Hello World program, what happens if you leave out one of the quotation marks? What if you leave out both? What if you spell print wrong? Let's try all of these. Print, hello, world, parenthesis, quote, and parent. Syntax error, invalid syntax, but interestingly, it waits all the way until here to show me the syntax error. Almost suggesting that everything that came before was valid syntax. What happens if you leave out both? Print, hello, world. Oh, I forgot the print. I want to leave that in for now. Invalid syntax at the same place. What about if we leave out only the back parenthesis? It's a totally different error. End of line while scanning string literal.
It doesn't recognize where the end of the string is.
What if we spell print wrong?
Pint.
Pint is not defined.
Which I'm kind of surprised that you didn't get a not defined error when there's no quotes. That I think
here. Yeah, why did I get an invalid syntax error instead of a name error? That's interesting. Yeah, that's a mystery.
This shit weird. I love it.
Yeah. Like I said, I told you we were about to get going. This kind of experiment helps you remember what you read. It also helps when you are programming because you get to know what the error messages mean. It is better to make mistakes now and on purpose than later and accidentally. So in a print statement, what happens if you leave out one of the parentheses or both? Invalid syntax, leaving out that one. It waits and waits and waits for me to say more. I'll finally give it what it wants. Make this bigger. And if I do it that way, invalid syntax.
No parentheses.
If you are trying to print out a string, what happens if you leave out one of the quotation marks or both? We did that above, right?
Yeah.
You can use a minus sign to make a negative number like -2. What happens if you put a plus sign before a number? What about 2 plus plus 2? Let's try that. Plus 2 is just 2. What about plus plus 2? How about a whole bunch of pluses and then 2? Apparently it just doesn't care about pluses beyond the first one.
2 plus plus 2 is still only 4. That's rad.
Yeah.
You would think that whenever, like, if you do 8, well, hold on, what was it? How did you do the times itself again? What was that?
Like times equal.
That's what it was. Is times equal.
That's something that you can do. Yeah, that's a times equal is an operator that you can use.
Gotcha.
Okay. In math notation, leading zeros are okay. What happens if you try this in Python? What about 0, 1, 1? Syntax error. Leading zeros and decimal integer literals are not blank. Wait, did I lose some of my window? I did. Let's just bring that back. Are not permitted to use 0 prefix for octal integers. I don't know what octal integers are in this context, but let's move on. What happens if you have two values with no operator between them, like 2 space 2? Invalid syntax. What about 2a? What about a2? That's interesting. 2a is an invalid syntax, but a2 is not defined. So a2, that tells me that a2 is a valid variable name and 2a is not a valid variable name. Okay, exercise 2. Start the Python interpreter and use it as a calculator. How many seconds are there in 42 minutes and 42 seconds? How would I go about that one?
42, wait, how many seconds are there? 42 times 60 plus 42.
Yep. How many miles are there in 10 kilometers?
I'm glad that hint's there. I wouldn't have been able to figure that out.
Yeah, it's a useful hint.
10 times 1.61.
I think it's divided.
Is it? Oh, miles. Yeah, that makes sense. Math has never been my strong suit, which is kind of the big struggle with programming.
What we need is the pint package. This is a total going off course here, but I'm going to allow it to happen for a little bit. 10 times ureg dot kilometer. It's that many kilometers. And if we try to multiply that times 1.61 times ureg dot km divide by ureg dot mile, we get 16.1 kilometers squared per mile. So it gives us a useful hint that we've done it wrong, and we can do it as divide, and we get 6.2 miles. I think that's a pretty neat little package.
Yeah, I mean that's helpful. I mean, it makes it so that you don't have to, think about it, and get it wrong. I'm not a huge fan of math.
In that case, you may not like this last one. If you run a 10-kilometer race in 42 minutes, 42 seconds, what is your average pace? Time per mile in minutes and seconds. What is your average speed in miles per hour? I think we can safely skip this bit.
That's fair. My math abilities are not a good indicator of my programming abilities, and I'm going to stick to that.
Okay. Chapter 2. Variables, expressions, and statements. One of the most powerful features of a programming language is the ability to manipulate variables. A variable is a name that refers to a value. Assignment statements. An assignment statement creates a new variable and gives it a value. Message equals and now, I'll just do that much of it. N equals 17, pi equals 3.141, and that's good enough for me. This example makes 3 assignments. The first assigns a string to a new variable named message. The second gives the integer 17 to n. The third assigns the approximate value of pi to pi. A common way to represent variables on paper is to write the name with an arrow pointing to its value. This kind of figure is called a state diagram because it shows what state each of the variables is in. Think of it as the variable's state of mind. Figure 2.1 shows the result of the previous example. Straightforward enough.
Huh?
Variable names. Programmers generally choose names for their variables that are meaningful. They document what the variable is used for. Variable names can be as long as you like. They can contain both letters and numbers, but they can't begin with a number. It is legal to use uppercase letters, but it is conventional to use only lowercase for variable names. The underscore character, underscore, can appear in a name. It is often used in names with multiple words, such as your name or airspeed of onlate and swallow. If you give a variable an illegal name, you get a syntax error. 76 trombones equal big parade. Cute. More at equal one bunch of zeros. Invalid syntax. Class equal advanced theo zim. Syntax error, invalid syntax. 76 trombones is illegal because it begins with a number. More at is illegal because it contains an illegal character, at. But what's wrong with class? It turns out class is one of Python's keywords. The interpreter uses keywords to recognize the structure of the program, and they cannot be used as variable names. Python 3 has these keywords. You don't have to memorize this list, and I'm not even going to read this list at this time. In most development environments, keywords are displayed in a different color. If you try to use one as a variable name, you'll know.
And lambda is my favorite one out of this list because I've used it in some code and I don't understand it whatsoever. I don't even know what it means, but it's useful. It helps.
It does help.
Yeah. I was using it to there was whenever I forget what command I was using, but I was adding a command to a button using and also we save this thing differently. I call it tkinter. You just call it, what do you call it?
tkinter because it's an interface for tk.
Oh, okay, that's funny. That makes sense. I like that. Okay, I'll have to get tkinter out of my dictionary. But anyway, I was assigning a command to a button, and what you would expect it to be would just instead of using that command upon pressing the button, it would use that command immediately as soon as the GUI opened. And so whenever I added lambda, it stopped that for some reason. I don't know why.
Oh, weird. I'd have to see that in context to understand why that worked.
Yeah. And also another favorite thing is I keep reading that camel casing is the way to go when it comes to defining your I know the word. We're learning the word. Variables. There we go. When defining your variables, but this is suggesting you do underscores, which I don't know. I just find that interesting.
Python, it's usually snake case, which is this way with underscores. JavaScript, it's camel case.
Gotcha. Okay. Huh.
Yeah.
Good to know.
All right, expressions and statements. An expression is a combination of values, variables, and operators. A value all by itself is considered an expression, and so is a variable. So the following are all legal expressions. 42, yep. N, it already knows that's 17. N plus 25, 42. Here we are back at 42. When you type an expression at the prompt, the interpreter evaluates it, which means that it finds the value of the expression. In this example, N has the value 17 and N plus 25 has the value 42. A statement is a unit of code that has an effect, like creating a variable or displaying a value. N equals 17, print N. The first line is an assignment statement that gives a value to N. The second line is a print statement that displays the value of N. When you type a statement, the interpreter executes it, which means that it does whatever the statement says. In general, statements don't have values, even though the print statement kind of looks like it has a value.
Which, I mean, it's just a string. Well, no, it's not a string at that point. It's not. It would just be an integer, right?
Yeah, that's interesting. What is it? It's just, I almost think of it as an image displayed on the screen.
It's just it's a general output.
I think that's a good way to look at it. Script mode. So far we have run Python in interactive mode, which means that you interact directly with the interpreter. Interactive mode is a good way to get started, but if you're working with more than a few lines of code, it can be clumsy. The alternative is to save code in a file called a script and then run the interpreter in script mode to execute the script. By convention, Python scripts have names that end in .py. If you know how to create and run a script on your computer, you are ready to go. Otherwise, I recommend using Python Anywhere again. I have posted instructions for running script mode at blah blah blah. Because Python provides both modes, you can test bits of code in interactive mode before you put them in a script. But there are differences between interactive mode and script mode that can be confusing. For example, if you are using Python as a calculator, you might type miles equal 26.2, miles equal 26.2, miles times 1.61, 42.182. The first line assigns a value to miles, but it has no visible effect. The second line is an expression, so the interpreter evaluates it and displays the result. It turns out that a marathon is about 42 kilometers. But if you type the same code into a script and run it, you get no output at all. Let's convince ourselves of that. Python evaluates the expression, but it doesn't display the result. To display the result, you need a print statement like this. So I'm gonna, I'll display.py, miles equal 26.2, miles times 1.61, Python display.py. It ran, but no output. So if I go back to vim display.py and do print, and then do Python display.py, sure enough, we get that 42.182. This behavior can be confusing at first. To check your understanding, type the following statements in the Python interpreter and see what they do. Python 5, what's 5 gonna do?
What?
If I hit enter on 5, what's it going to do?
Is it just gonna return 5 or nothing?
It's gonna show
or
5.
not nothing.
It's gonna show
Yeah.
5.
Yeah.
What about if I hit enter on x equals 5?
X? I don't know. 5? That's a great question.
Let's see. Shows nothing. That's because
I guess because you never call the variable.
that's because if we go back, that was a statement, has an effect, but it doesn't have a value. Like, what if we try to do something weird and say type of x equal 5? I don't know if that's even... Yeah, it doesn't make sense.
Well, I mean, if you do x equals 5 and then do type of x, wouldn't that...
Sure. You can do type of x because x is an expression.
You get interesting. It's just that whenever you do type of x equals 5, you can't like when they're defining the variable.
You can't ask the type of a statement.
Yeah.
What if we did type of print 5? I'll make it a string.
None type. I love that.
Notice that it also printed 5. What about type of print? Built-in function or method. The plot thickens.
Type.
Oh, by the way, Kay asks, which book is this? Sorry, Kay, to keep you waiting there. This is Think Python by Alan Downey.
You know, I'm a fan of this. If you do a type of type, the class is type.
Oh, really? I didn't think to do that. What about type of type? Oops.
Unmatched.
Of course, I have to do this one more time.
But now let's take it a little bit deeper. If you do type of 5, it's probably gonna be type, huh?
Let's see. Type of 5 is going to be int. Type of type int is going to be type, and type of type is going to be type. So yeah.
Yes.
That's funny.
Typeception.
Let's see. Let's get back to where we were. Okay. So again, if it's 5, it outputs 5. If it's at equal 5, it doesn't output. What would it do if I hit enter on x plus 1?
It's gonna return 6.
Yeah. It's gonna display 6.
I keep saying return as if you're typing specifically return. So what would you say is the difference between using return and it returning 6 and it giving you 6 because you did the statement or the thing?
I was trying to avoid the word return because functions return values. And the interpreter isn't a the console isn't a function, but it does in some sense of the word, it returns a value to you. So it's okay to say it returns 6. I think I'm being overly strict about how I use my language.
So you say display. Is that the term that we want to use? Because like ultimately, what is it doing at that point? I guess we're going a little bit deep at that sense, but what is it really doing?
I mean, it is returning a value to us. Like we gave it something and it returned something. So in that sense, we could say return.
Gotcha.
In my head, return has the context of making me think of functions, which are a different thing than the interactive console. But that's why I was getting hung up on it. But it's not a very important point, I think.
No, it makes. I mean, so I just went ahead and did like x equals 5, then return x, and it doesn't work because it's outside of a function.
Right.
So you make a fair point.
Yeah, and return is a keyword in Python, so it means something pretty specific too.
Yeah.
Wonder if I can bring this thing over. No. Yeah.
It's something to look into later. Just out of curiosity. Like it's not going to teach me anything, just to learn the specific word for what it does whenever it gives you the information in console. But just for shits and giggles, it's nice to know.
Yeah. CTY from Twitch asks, "Is this the hamburger?" No, this is not Mr. Hamburger. This is Whenmill.
No, I'm the TV actually.
You are the TV. I kind of want to bring that TV up on the stream. Since we mentioned it, I'll take a moment to make that happen.
Pog. Honestly, what's really disappointing is that my streaming career was very, very short-lived, and as proud as I am of creating this thing, I never get to use it, or I almost never use it.
Creating what thing? Oh, your
yeah.
Gotcha.
Because it like I had the idea in my head to do it, and then like to actually accomplish it, I had to find this software. It's like Magic. It's like supposed to be a thing that reacts to music, but it's reacting to my voice instead.
Oh, the TV is something that you created.
Yeah, no, 100%. Yeah.
Oh, I thought it was like a built-in thing with ping.gg.
No,
that's so much cooler that you did this.
Yeah, I used Magic, and then because Magic doesn't display the movement of the sound in a way that can be pulled by Streamlabs, I had to use this other software called Spout Receiver, which then creates a display that can be brought into Streamlabs. So it's going from Magic to Spout Receiver to Streamlabs to many cams and then to, what is this website called again?
Ping.gg.
Ping.gg. So it's just traveling all over the place to be able to actually be seen.
Here we go. Browser source. Add source.
In which it's going to ping.gg and then being transmitted onto twitch.tv.
Well, then they transmit it to Streamlabs desktop on my machine.
Oh my god.
And that transmits
it. Doesn't stop.
That transmits it to Twitch and to YouTube at the same time.
God, my TV's everywhere.
Wait, that's the wrong... Why is it not doing the right thing? Oh, that's because I need to actually paste in the source. Okay. Your TV is on the stream.
Where are you, TV? Oh. I'm seeing your game of life.
Yeah, I got the wrong thing. I got the wrong window open somehow. Let me get this fixed up.
Maybe it's not worth it. It's not worth it. But CTY did ask, what do you think about the course from Pycharm Edu Team? I'm doing that to learn Python.
Oh, I've thought good things about I like JetBrains, I like Pycharm, and yeah, they probably have a good thing put together.
Yeah, and I see my little TV. I'm up there. I'm proud.
Yeah. So
but I didn't know that JetBrains actually made their own course.
Yeah,
that's pretty cool.
They do have a suite of educational materials. They made their own programming language too.
Is it any good?
I think so, yeah.
Have you heard at least? Huh. Interesting.
It's called Kotlin. I think Google is a big proponent of it, like for Android software. Because Android was Java-based, and Kotlin is an extension of Java. Or is related to Java in some way. Or maybe it transpiles to Java. It definitely runs on the Java virtual machine.
Yeah. There's too many programming languages. I've had enough. Like I remember whenever I first started learning about and like thinking about learning programming, and there was there was C#, C++, Java, Python, the basic ones. But now I'm hearing about what's that one that people keep saying you need to learn how to do for like tech interviews and stuff.
For tech interviews?
Yeah, it's like a super bizarre one. Hold on. There's some like really weird sounding programming languages. God,
could it be Lisp?
Remember. No.
Lisp is more for like algorithm development and machine learning somewhat.
I will find the answer to my question. Give me just a second.
Okay.
Leet code. That's what it is.
Oh.
Like, what the?
Well, that's not a language. That's a website.
Oh, it's a that Oh, wow. That shows how much I know.
Yeah, it's a website with coding challenges. Nick White made a bunch of videos on Leet code and got big because of it on YouTube.
Maybe I should go on. Well, I mean, Leet code actually proves nothing. Will not help me at all unless it's specific to Python only at a certain point.
I think they have Python challenges.
Oh,
I think they have it in a variety of languages.
Might be worth picking up my streaming hat again to do some Python Leet code.
I recommend Code Wars. I find it more friendly as a site.
Code Wars.
It's the same concept. You have coding challenges to solve.
Sick. All right, I've just got a tab open. I'll look at that later. Ooh.
CTY says waste of time for me. What was a waste of time? Do you mean
Kotlin, I think.
or
Which, I mean, I guess, like, it depends. Like, I'm guessing Python would be your first language, huh? Oh, LeetCode.
LeetCode and CodeWars, etc. CTY is saying. Okay.
Yeah.
Wonder why. All right, let's continue. Oh, now put the same statements in a script and run it. What is the output? So vim script.py. Oops. Vim script.py. Print 5. Print x equal 5. I'm a little nervous about that line. Python script.py. Yeah, it outputs 5, but then it says x is an invalid keyword argument for print. And that has to do with the fact that print is a function, and we haven't learned about function in this book yet, so let's not worry about... What is that? CTY says I can do them on phone, so I would only do them on phone when I'm on PC. I want project. Oh, you'd rather spend your time doing project as opposed to LeetCode problems. That's valid. That is valid. Okay, order of operations, 2.5.
It's middle school math class again.
Yeah, I kind of feel like we can gloss over. Order of operations, PEMDAS, parentheses, exponent, multiplement, division, operators, evaluated from left to right. I don't work very hard to remember the precedence of operators. If I can't tell by looking at an expression, I use parentheses to make it obvious. Okay. Well, we made good time of that one.
Yes, it was efficient, as it should be. At least with the order of operations, I can live without it.
Yeah, just use parentheses to make things obvious, like he said.
Yeah.
String operations. In general, you can't perform mathematical operations on strings even if the strings look like numbers, so the following are illegal. Chinese minus food, eggs divide by easy, or eggs over easy. Oh, that's cute. Third times a charm. But there are two exceptions, plus and times. The plus operator performs string concatenation, which means it joins the strings by linking them end to end. So let's go back to Python. Oh, CTY says, can I ask you for something? You can ask, yeah. First equal throat, second equal warbler, first plus second equals throat warbler. The times operator also works on strings. It performs repetition. For example, spam times 3 is spam, spam, spam. This I gotta see. Yeah, spam times spam. What about spam times spam? Can't multiply non-int of type string. Type error. Not allowed. This use of plus and times makes sense by analogy with addition and multiplication. Just as 4 times 3 is equivalent to 4 plus 4 plus 4, we expect spam times 3 to be spam plus spam plus spam, and it is. On the other hand, there is a significant way in which string concatenation and repetition are different from integer addition and multiplication. Can you think of a property that addition has that string concatenation does not? I can think of one. I don't remember I don't remember the name of it though.
Describe it to me.
It's like, well, 3 plus 5 is the same as 5 plus 3, but spam plus eggs is not the same as eggs plus spam.
That makes sense.
Yep.
So, but one. Spam, you can't do. Okay. I was just looking at the x plus spam. I was just thinking about how you can do the x plus spam. So x plus
X spam. Plus spam? Oh, eggs.
Isn't that what you said?
I said eggs.
Oh,
eggs plus spam.
but that does bring up a fun little error: unsupported operand types for plus, int, and string.
Mm-hmm.
That's a fair point. I see. I understand what you're actually saying now.
Yeah, that's the point I'm making.
I see. I understand.
Not if 3 plus 5 are strings though. Oh, CTY had something to say. Also, the black sand timer is up, so that means it's time for a 5-minute break, which we'll get into in a moment. What is math.exponent and math.exp1, and why not just use .pow if they do the same thing? I don't know what .exp1 is, but I think math.exponent would allow you to do things with variables that you can't, with variable quantities that you can't do with .pow. That's kind of my thought. And then not if 3, yeah, true. If 3 plus 5, if 3 and 5 are strings, then string 3 plus string 5 is different to string 5 plus string 3. Which is kind of interesting. Okay, I don't know about you, but I could use a drink of water.
That works for me. I could take a short break.
Cool. I'll be right back.
Okie dokie.
Where did the... Oh, there it is. Just needed a moment to start up. CTR points to docs.python.org 3 library math.html. That equals math.expm1. It's expm. I was wrong. Let me take a look at this. Can I copy this? I think I need to open up a different Twitch window to be able to copy that thing. Oh, exp minus 1. Oh, exp minus 1. Oops. Whoa, we got some echo going on. That's better. I don't know why exp m1 matters. But TV face Whenmill. Shall we resume?
Yes, I will mute on occasion because I'm eating Cheez-Its.
Okay. Okay, as long as you can unmute when it's needed.
Absolutely.
Okay, 2.7 comments. As programs get bigger and more complicated, they get more difficult to read. Formal languages are dense, and it is often difficult to look at a piece of code and figure out what it is doing or why. For this reason, it is a good idea to add notes to your programs to explain in natural language what the program is doing. These notes are called comments, and they start with the hashtag symbol. What happens if I do a comment in the interpreter? Hey, it just does nothing. Compute the...
No, it's a comment.
What?
It just is a comment.
It just is. Okay.
Yeah.
But it doesn't make an output, is the point I'm making.
Yeah. Which I'm surprised we're not skipping this one. You don't believe in comments.
Well, we'll get there.
I'm gonna believe for this consistently.
Okay. Doing it right for this reason. These notes are called comments. Okay. Compute the percentage of the hour that has elapsed. Percentage equals minute times 100 divided by 60. Oh, times 100 because it's percentage. Okay. In this case, the comment appears on a line by itself. You can also put comments at the end of a line, percentage of an hour. Everything from the hashtag to the end of the line is ignored. It has no effect on the execution of the program. Comments are most useful when they document non-obvious features of the code. It is reasonable to assume that the reader can figure out what the code does. It is more helpful to explain why. This comment is redundant with the code and useless. V equals 5. Assign 5 to V. This is the kind of comment I would rail against. This comment contains useful information that is not in the code. V equals 5, velocity in meters per second. Good variable names can reduce the need for comments, but long names can make complex expressions hard to read, so there is a trade-off. 2.8 Debugging. 3 kinds of errors can occur in a program. Syntax errors, we've seen some of those. Runtime errors and semantic errors. It is useful to distinguish between them in order to track them down more quickly. Syntax error. Syntax refers to the structure of the program and the rules about that structure. So like, there's the example. Syntax error, unmatched right paren. For example, parentheses have to come in matching pairs, so paren 1 plus 2 paren is legal, but 8 paren is a syntax error. If there is a syntax error anywhere in your program, Python displays an error message and quits, and you will not be able to run the program. During the first few weeks of your programming career, you might spend a lot of time tracking down syntax errors. As you gain experience, you will make fewer errors and find them faster. Runtime error. The second type of error is a runtime error, so called because the error does not appear until after the program has started running. These errors are also called exceptions because they usually indicate that something exceptional and bad has happened. Runtime errors are rare in the simple programs you will see in the first few chapters, so it might be a while before you encounter one. Semantic error. The third type of error is semantic, which means related to a meaning. If there is a semantic error in your program, it will run without generating error messages, but it will not do the right thing. It will do something else. Specifically, it will do what you told it to do. Identifying semantic errors can be tricky because it requires you to work backward by looking at the output of the program and trying to figure out what it is doing. Okay, and the glossary, once again, we can gloss over, because unless there's any of these things that you don't think you understood as we went through it, but I think we're fine with all of these.
Yeah, and I do want to say though, I have a lot of customer service under my belt, and because of that, I am an expert at determining semantic errors, because like trying to figure out where like a customer's brain has been this whole time, and how they managed to break something the way that they did. It's the exact same thought process as trying to figure out what the hell your code did.
Interesting.
Same exact thought process to figure that shit out. It's frustrating but fun. It's more fun whenever it's a computer. It's more frustrating when it's a person, because they tend to yell back at you.
Yeah, the computers don't yell as much.
Yeah.
Okay.
Thankful to not be doing that anymore. Anyway, go on.
There you go. Exercise 1. Repeating my advice from the previous chapter, whenever you learn a new feature, you should try it out in interactive mode and make errors on purpose to see what goes wrong. We've seen that n equal 42 is legal. What about 42 equal n? Any guess on what this is going to tell us? I did 24. Let's do 42. Let's see what it does. Syntax error cannot assign to literal. What about x equal y equal 1? Apparently you can do that. Weird. In some languages, every statement ends with a semicolon. What happens if you put a semicolon at the end of a Python statement? So let's try n equal 42 with a semicolon. It still stored 42 to n, so it doesn't have the number. CTY says no number. I don't know what you mean, CTY. Yeah?
One thing I was curious about was if you change the value of y, because x equals y, which equals 1, will it change the value of x?
Oh, interesting. What if we change?
It does not.
Looks like it separately stores the value to x and to y. Yeah. But I've never seen this used in an actual program, so I wouldn't worry about it too much. But that was an interesting question.
Yeah, but so I guess I'm just thinking of a use case for that, which would likely just be if you want two variables to be equal at first, but then change and then diverge just after that. But even then, you can just do it on two separate lines.
Y equal 1.
Yeah, exactly.
It would be much less confusing.
Yeah.
Yeah, I agree. Okay, semicolon was fine. What if you put a period at the end of a statement? That's different.
It turned it into a float.
Interesting. How about what's something else? Print and period. Invalid syntax. What about n equal 42 space dot? Then it's invalid syntax. Interesting. In math notation, you can multiply x and y like this. What happens if you try that in Python? X, y. Nope, xy is not defined, even though x obviously and y. Wait a second. We're back to x and
You
y
said-
equal 1.
Yeah, you set
Oh,
them to
okay.
1 individually.
I did do that. Okay. For a second, I was like, "Whoa, what just happened?" This is weird. Practice using the Python interpreter as a calculator. Gets kind of mathy. I don't know if we want to do these. Yeah, these are
No.
like math word problems. We can skip these.
I cannot stand math word problem. But you know what I mean.
Yeah.
I never passed algebra.
Ooh.
Yeah. Well, no, I passed algebra 1. Excuse me. I never passed
There you
algebra
go.
2.
Oh, okay.
That's when I got put into Math Essentials, the remedial program.
Oh.
Yeah, no kidding. I told you I was bad at math.
Well, we're on to functions. This is good. Functions are good. Chapter 3, Functions. In the context of programming, a function is a named sequence of statements that performs a computation. When you define a function, you specify the name and the sequence of statements. Later, you can call the function by name. Function calls. We've already seen one example of a function call. Type of, well, yeah, we'll do 3. Why not? Type of 42 class int. The name of the function is type. The expression in parentheses is called the argument of the function. The result for this function is the type of the argument. It is common to say that a function takes an argument and returns a result. The result is also called the return value. Python provides functions that convert values from one type to another. The int function takes any value and converts it to an integer if it can, or complains otherwise. Int of string 32 is just 32, and if we do type of int of string 32, what will we get?
Int?
Yeah. But if we do int of hello,
that's not gonna work.
That's not gonna work. What if we do int of 5? Oh, that's fine. Int of type of 5 or 6. Also doesn't work. Int can convert floating point values to integers, but it doesn't round off, it chops off the fraction part. Int of 3.999. Okay, I have to try this. How far can I go with these 9s and still have it end up as 3? Haha, I broke it.
So why did it decide to round up that time?
Let me find the cutting off point. I think there's a limit to how long of a string, how long of a float literal it can pay attention to. So even before I tried to turn it into an int, it had already interpreted it as a 4.0 floating point number.
Yeah. Which, this is reminding me that there's 2 different ways, like, I don't remember if they went over this, but they're the 2 different ways to divide, in which one case it will show it as a float and the other one will round. Which way? What was that?
This book hasn't gone over it yet. Like,
okay.
3 divided by 5, 3 divided by 5 is 0.6, but 4 double divided by 5, 4 double divided by 5 is 0. And 5 double divided by 4 is 1. Like, let's use 3 and 4 just because that makes it easier for me to think about. 0.75 rounds down to 0. 1.33 rounds down to 1. And CTY says, what about int of 3.9 E10? Just that. 3.9 with some zeros.
That actually, now this is also, once again, this is jogging my memory from whenever I was learning. What I'm trying to think of how it is, you can choose, there's something you can do to make it round up. Is it dot round? Like, is that what it is?
Well, you could do seal. Or I think it's math.
That's what it is. Yeah.
I never know how to spell seal. Yeah. Interestingly, we can go math.seal at 4.01. We still get 5. What about like a bunch of zeros? Like an unreasonable number of zeros. Yeah, it falls down.
Oh, and that's gonna round up no matter what.
It's 4.001. So again, when the Python interpreter gets this literal input, it chops it off at like somewhere around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is okay, but what if we do a few more? 11, 12, 13, 14, 15, 16. There it is. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16. Oh, that makes sense. It only has 16 bits for reading literals. Right?
Yeah, that makes sense.
Let me just double check on that length of... If I take this as a string, it should be 17 because of the dot. Yeah. But length of this one should be 18 because it's one more than 16, and then the dot is another one more. Oops, I want the length of that.
How many more can you do? Like, so does it matter whether or not any of those are before the decimal point? Like, could you add more if it's in front of the decimal point?
I bet it's the same amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This one should be okay. But if I add one more, it's not okay.
Gotcha. So that makes me wonder, now I can learn what the highest possible value is in Python. Let's see. What is 17 figures? 17 zeros. No, excuse me, sorry. Yeah, no. 17 zeros and a number. Let's see, how many is that? Sexdecillion. Oh no, sorry, that's groups of 3 zeros. I did that wrong. How many zeros is that? It would be 99 quadrillion. No, 999 quadrillion. Yeah. And then the 9999 and so on and so forth.
Sorry,
wait a minute. What are you doing here? What is this?
What is this nonsense?
I looked away for a second.
Let's just... make a fresh start. There. How's that look?
Beautiful.
Okay. It rounds off the fraction part. It chops off the fraction part, so int of minus 2.3 is minus 2. Float converts integers and strings to floating point numbers. Float of 32 and float of 3.14159. I don't care if I got the number wrong. We're not using this for any actual calculations. Finally, string converts its argument to a string. So str of 32, string of 3.141. How about string of type of 33? What is this going to give?
Int. No, wait, I did it wrong because it's got the quotations. There we go. String of type of type.
This is just getting silly.
Which it does the exact same. It ends up being the exact same thing. That's always fun. I love it when it's like you just go bonkers with it and it just ends up being the exact same thing. Oh.
1, 2, 3, 4.
Hello world.
Yeah, same thing. That was fun and unnecessary.
That's what you're talking about, keeping it fun.
Yeah, that's right. Math functions. Python has a math module that provides most of the familiar mathematical functions. A module is a file that contains a collection of related functions. Before we can use functions in a module, we have to import it with an import statement. Import math. The import statement creates a module object named math. If you display the module object, you get some information about it. Math. Module math from users Erik Anderson, blah, blah, blah. The module object contains the functions and variables defined in the module. To access one of the functions, you have to specify the name of the module and the name of the function separated by a dot, also known as a period. This format is called dot notation. Ratio equals signal power divide noise power. Decibels equals 10 times math.log10 of ratio. Radians equals 0.7. Height equals math.sine radians. I'm not going to bother typing those ones out.
L plus ratio plus your maidenless.
What about plus ratio?
Oh, I was just looking at the log 10 ratio. It said L plus ratio plus maidenless. I was just being an internet degenerate. I'm sorry.
Okay. I just got lost, and now my brain is blanking.
You know, it's fair. It's Friday evening.
It is Friday evening.
Which I've been forgetting the real time because whenever I reset my PC, it shot me back 2 time zones for some reason.
Oh, weird.
Oh my god. Yeah.
That's kind of funny.
Yeah, and I still haven't fixed it. But you know what? No time is good as the present.
Sure.
And nope.
Well, you can't change it if you set it automatically.
Oh, you can see that. That's so funny. I didn't.
I hit it from the stream, but yes, I can see it.
Huh. Yeah.
Okay, we're back to the TV.
Back
You
to
didn't
TV.
you didn't put anything sensitive on the screen, so
Yeah.
it's okay.
No. I forgot because the whole way that I've got the TV showing is just so jank. Okay. God. It's like it says it's got. Oh wait, I'm looking at Pacific time. No der. There we go. And we're back to normal. Okay, we're all good.
Right on. All right. This is some math stuff. I don't think it's the important point here is math dot notation lets you get math dot something, like pi is a value. And you can do math.sqrt. So you can get functions from in the math thing. You can also do math.sqrt of math.pi. 1.772. That's a nice number. 3.3 composition. So far we have looked at the elements of a program, variables, expressions, and statements in isolation without talking about how to combine them. One of the most useful features of programming languages is their ability to take small building blocks and compose them. For example, the argument of a function can be any kind of expression, including arithmetic operators. X equal math.sine degree divide by 360 times 2 times math.pi. And even function calls, math.exp, math.log, x plus 1. Almost anywhere you can put a value, you can put an arbitrary expression. With one exception, the left side of an assignment statement has to be a variable name. any other expression on the left side is a syntax variable. I think we saw an example of that a little while ago. We will see exceptions to this rule later. Minutes equal hours times 60 is right. Hours times 60 equals minutes is wrong. Hours times 60 equals... Well, first I have to define minutes. Actually, this is pretty interesting. What will it complain about first? Can't assign to operator. Okay. Adding new functions. So far we have only been using the functions that came with Python, but it is also possible to add new functions. A function definition specifies the name of a new function and the sequence of statements that run when the function is called. Here's an example. We can def print lyrics, print lumberjack, print sleep work. Def is a keyword that indicates that this is a function definition. The name of the function is print lyrics. The rules for function names are the same as for variable names. Letters, numbers, and underscores are legal, but the first character can't be a number. You can't use a keyword as the name of a function, and you should avoid having a variable in a function with the same name. The empty parentheses after the name indicate that this function doesn't take any arguments. The first line of the function definition is called the header. The rest is called the body. So we've got header and body. The header has to end with a colon and the body has to be indented. By convention, indentation is always 4 spaces. The body can contain any number of statements. The strings in the print statement are enclosed in double quotes. Single quotes and double quotes do the same thing. Most people use single quotes except in cases like this where a single quote, which is also an apostrophe, appears in the string. Oh, I didn't even notice that. I'm okay. So the single quote there and the double quotes here. All quotation marks, single and double, must be straight quotes, usually located next to enter on the keyboard. Curly quotes, like the one in the sentence, are not legal in Python. If you type a function definition in interactive mode, the interpreter puts dots to let you know the definition isn't complete. To end the function, you have to enter an empty line. That's what I just did. Defining the function creates a function object which has type function. If I print lyrics, it's a function at such and such place. If I ask for the type of print lyrics, I get that. What if I get a type class function? What if I do print lyrics of print lyrics? Print lyrics takes 0 positional arguments, but 1 was given. Type error. Fair enough.
But what does work is if you put the function within itself.
Recursion.
Yes. Didn't think I haven't touched recursion. I didn't think this was actual working recursion, but now I've got. Let me just real quick throw this onto my.
Well, what you've
TV.
got is what looks like you've got is an infinite loop.
Yes. I broke it. It
And
did go on for quite some time.
And was that because of recursion or because of some other method of loop?
It was because of recursion. I did within print lyrics. I called print lyrics after saying print am lumberjack. It repeated 992 times, and that was the maximum. Yeah, that was maximum recursion depth.
This I gotta try now.
Thing.
Previous line repeated 992 more times. 92, 93, 94, 95, 96. So almost 1,000. What if you needed to go like a maximum recursion depth? Like if you were doing a factorial of a number greater than 1,000.
I guess you're SOL.
I
or
guess
maybe
so.
it's just Maybe. Well, so now is it a limitation of Python in general? Is it a limitation in this, what you call it, command line?
It's probably in Python in general.
Oh.
It may be configurable if you're a ninja. I don't know if you can configure the Python runtime in that way. The syntax for calling new functions is the same as for built-in functions. Print lyrics, yeah, we did that. Once you have defined a function, you can use it within inside another function. For example, to repeat the previous refrain, we could write a function called repeat lyrics. Def repeat lyrics, and then call repeat lyrics, and it says the Lumberjack song twice. But that's not really how the song goes. 3.5, definitions and uses. Pulling together the code fragments from the previous section, the whole program looks like this. Print lyrics, repeat lyrics, repeat lyrics. This program contains two function definitions, print lyrics and repeat lyrics. Function definitions get executed just like other statements, but the effect is to create function objects. Creates a function object. The statements inside the function do not run until the function is called, and the function definition generates no output. As you might expect, you have to create a function before you can run it. In other words, the function definition has to run before the function gets called. As an exercise, move the last line of this program to the top so the function call appears before the definitions. Run the program and see what error message you get, okay? And I'll, this time, just copy paste it all. Python error.py. Repeat lyrics is not defined. Now move the function call back to the bottom and move the definition of print lyrics after the definition of repeat lyrics. So I have to remember how to use yank. It's V for visual, $, X to pull it out, and make a new line, and P for paste. Okay. So put repeat lyrics at the bottom. As an exercise, move the last line of this program to the top. Okay, now move the function back to the bottom and move the definition of print lyrics after the definition of repeat lyrics. What happens when you run the program? So let's analyze this. Oops. We're going to define repeat lyrics, which includes calls to print lyrics. Then we're going to define print lyrics, which has the Lumberjack song. Then we're going to call repeat lyrics. What's your prediction on what it's going to do? Do you have a prediction on what it's going to do?
Oh, I'm sorry. I for some reason I thought that was a hypothetical. No, it's gonna repeat the lyrics.
Even though it defined repeat lyrics before it knew what repeat lyrics is, or before. Oh, I'm getting worn down.
Well, that's a good. Actually, no, I didn't even think about that part. You're right. It'll just say that it's not defined.
Let's find out. Let's find out. It printed the lyrics.
Huh?
So let's look at that again. We did a definition that says, if I call repeat lyrics, you're going to call print lyrics. This is print lyrics. Now call repeat lyrics, and only then does it call print lyrics. So it doesn't care about what's inside of print lyrics until it actually executes.
That makes sense.
Which
is just weird because I'm surprised because there are times where I call one function ahead of the other, and the only reason it doesn't work is because of the order in which they are defined. But it's probably something to do, like, it might just be a bit more complicated than I'm thinking it is.
Possible. What happens when you run this program? 3.6, flow of execution. This might be the last chapter for me for tonight. This is kind of a big one. It's an important
Okay.
chapter. To ensure that a function is defined before its first use, you have to know the order statements run in, which is called the flow of execution. Execution always begins at the first statement of the program. Statements are run one at a time in order from top to bottom. Function definitions do not alter the flow of execution of the program, but remember that statements inside the function don't run until the function is called. A function call is like a detour in the flow of execution. Instead of going to the next statement, the flow jumps to the body of the function, runs the statements there, and then comes back to pick up where it left off. That sounds simple enough until you remember that one function can call another. While in the middle of one function, the program might have to run the statements in another function, then while running the new function, the program might have to run yet another function. Fortunately, Python is good at keeping track of where it is, so each time a function completes, the program picks up where it left off in the function that called it. When it gets to the end of the program, it terminates. In summary, when you read a program, you don't always want to read from top to bottom. Hey, Icarus T7 just followed, and I almost got a little startled there. Thanks for the follow, Icarus. It was a little, the follow noise was a little loud in my earphones, not gonna lie. If in summary, when you read a program, you don't always want to read from top to bottom. Sometimes it makes more sense if you follow the flow of execution. 3.7, parameters and arguments. Some of your functions we have seen require arguments. For example, when you call math.sign, you pass a number as an argument. Some functions take more than one argument. Math.power takes two, the base and the exponent. Inside the function, the arguments are assigned to variables called parameters. Here is a definition for a function that takes an argument. Def print twice of Bruce, print Bruce, print Bruce. This function assigns the argument to a parameter named Bruce. When the function is called, it prints the value of the parameter, whatever it is, twice. This function works with any value that can be printed. All right, let's go back to Python and def print twice of, print twice of Bruce. Print Bruce. Print Bruce. Now print twice of spam. Print twice of 42, and I think we get the idea. Print twice of math.py. The same rules of composition that apply to built-in functions also apply to programmer-defined functions, so we can use any kind of expression as an argument for print twice. Like print twice of spam times 4. Patin twice, oops. Sign that I'm getting tired. Print twice math.cosine math.py. Same idea, right?
Yeah.
The argument is evaluated before the function is called, so in the example, the expressions spam times 4 and math times cosine math.py are only evaluated once. Oh, that's interesting. You can also use a variable as an argument. Michael equals Erik, the half of b, print twice Michael, and it prints it twice. The name of the variable we pass as an argument, Michael, has nothing to do with the name of the parameter, Bruce. It doesn't matter what the value was called back home in the caller. Here in print twice, we call everybody Bruce. I hope you like being called Bruce.
I can see how that would get really confusing, though, if you aren't consistent with the naming pattern. I guess, like, even...
Yeah.
I guess.
For sure.
Yeah. Which, I mean, like, in my own program, like, I don't... Like you saw what I was doing last night. I just kept... when I was calling in functions, it was just the same thing over and over and over again, even though technically, I guess it didn't really have to be, just as long as I had 3 variables being called into it, right?
Yeah, it could have been Bruce, it could have been Brian, it could have been Michael. Yeah.
And any one of the variables could have actually just been, I don't know, the entire script for the B movie or something. It wouldn't have mattered.
Right. No, it wouldn't have mattered. Except it would have mattered to you.
Yeah, that would be an unfortunate thing to include in my program. Yeah.
Mm-hmm.
Can't imagine it would be helpful.
I can't imagine either, yeah. Okay, variables and parameters are local. When you create a variable inside a function, it is local, which means that it only exists inside the function. For example, def cat part 1, part 2, cat equals part 1 plus part 2, print twice of cat. This function takes 2 arguments, concatenates them, and prints the result twice. Here's an example that uses it. So let's define this function, def cat twice of part 1 comma part 2, colon, spaces, cat equal part 1 plus part 2, print twice of cat, define the function, line 1 equal Bing tittle. What did I do? Oh, notice how I did the wrong kind of quote there, so it failed. Line 1 equal that, line 2 equal tittle bang, cat twice of line 1 comma line 2, and it prints the Bing tittle bang twice.
Yeah.
When cat twice terminates, the variable cat is destroyed. If we try to print it, we get an exception. Print cat. Name cat is not defined. Stack diagrams. To keep track of which variables can be used where, it is sometimes useful to draw a stack diagram. Like state diagrams, stack diagrams show the value of each variable, but they also show the function which the variable belongs to. Each function is represented by a frame. A frame is a box with the name of the function beside it and the parameters and variables of the function inside it. The stack diagram for the previous example is shown in figure 3.1. So main has line 1 equal to Bing tittle and line 2 equal to tittle bang. Cat twice has part 1 equal to bang tittle and part 2 equal to tittle bang. Cat twice has cat equal to bang tittle bang. And print twice has Bruce equal to Bing tittle bang. So you have the same data in cat as you have in Bruce. And you have the same data in part 1 as you had in line 1, even though they have different variable names. And Python keeps track of it all because it feeds one thing to the next. Is that clear?
Yes. Okay, so I understand it, how it works. It's just that it's one of those things where if it's not my own function that I am then following it that way, it's so much harder to keep track of it, basically.
You're saying because it's his function, it's harder to keep track of?
Yes.
That's fair. The frames are arranged in a stack that indicates which function called which, and so on. In this example, print twice was called by cat twice, and cat twice was called by main, which is a special name for the topmost frame. When you create a variable outside of any function, it belongs to main. Each parameter refers to the same value as its corresponding argument. So part 1 has the same value as line 1, part 2 has the same value as line 2, and Bruce has the same value as cat. If an error occurs during a function called, Python prints the name of the function that called it, and the name of the function that called that, all the way back to main. For example, if you try to access cat from within print twice, you get a name error. What's happening here?
I'm going through it. What happened to cat? It broke.
If you try to access cat from... Oh, I get it. So if we redefine print twice, oops. Def print twice. If we try to print at, if we tell it that's what we want to do in print twice, and then now we say cat twice of A, comma B. Oh, that's all wrong. Anyway, I think I might have hit a wall for tonight.
That's fair.
Let's read through the rest of this section, and we can maybe come back to it another day when I'm fresh and I've had some time to review this part of the book. The list of functions is called a traceback. It tells you what program the file the error occurred in, and what line, and what functions were executing at the time. It also shows the line of code that caused the error. The order of the functions in the traceback is the same as the order of frames in the stack diagram. The function that is currently running is at the bottom. I think what happened is, I don't know what happened.
It broke.
It broke.
And sometimes that's just enough to know. And this is one of those times it's enough.
Yeah. We do know that inside of main is cat twice, and inside of cat twice is print twice, and inside of print twice is print cat, and cat was not defined. So he went and redefined print twice, which was what I was trying to do, but I made some other error. Ooh, fruitful functions and void functions. That's a good section.
You think you've got the brain power for it?
I don't know. Let me put on the rest timer. Take a little bit of mental defocus time.
I'm gonna shove some more Cheez-Its in my mouth while you're defocusing.
I'm gonna fetch some water more too. That's a sand timer. I think I don't have it in me to do section 310 right now.
All right, that's fair. For another day, then.
Another day for section 3.10.
Absolutely. All right, well, it's been a blast. Thanks for having me.
You're welcome. It's been good, and I think I think this is a really good book. I'm glad we're going through it.
Yeah, it's definitely getting like I'm liking the speed of the progress, if I'm being honest, because I know that I think it probably took me about like 3 days to get here, whenever I was first learning programming. So,
Interesting.
not with this book, but 3 days to get to this point, because I was doing maybe like an hour a day, mostly solo, up until I actually started getting viewers and stuff.
Oh yeah.
Yeah. But yeah. Anyway.
I just mailed in my work laptop today. I finished a job.
Oh, nice. Congrats.
Thanks.
And how long to start your next one?
I have a week off, and that plus Memorial Day.
Nice.
So a nice long weekend. Gonna watch some movies. Gonna drink some tea. Gonna probably do a lot of streaming.
Awesome. I was actually just digging through my my hoard of tech stuff because I have a mini computer that I use for like a server if I wanted to, and so I'm thinking about rebuilding that game server I was talking about before.
Oh, that's cool.
It's got a special plug for the little computer. Can't find it. Don't know where it is. So, but that's just what happens when you move. So
yeah, stuff just gets mixed up here and there.
Yeah, it's somewhere, I'm sure. But once I have that set up, I'm gonna try to set up that server, see if I can, run Linux without breaking it.
Yeah. I was watching a streamer today who runs his Linux in a virtual box partly because when he inevitably breaks it, it's easier to spawn a new one.
Yeah. Oh god, that's not such a bad idea. Maybe I should do that.
Oh, Kay says, Eric, would you mind to tell me a bit more about yourself? Yeah, I can say a bit more about myself. If there's anything in particular you want to ask, and I'll answer whatever I'm comfortable answering. But I'm where to start? I went to school for chemistry and music. I played trombone in college and got pretty good at it. I was in the symphony orchestra and the top jazz ensemble. And then I went to
Oh, sorry to interrupt, but I was gonna say I was a trumpet player, but I don't know if my ego was clear enough. But anyway, sorry to interrupt. Go on.
I went to grad school for chemistry. Might as well say where. I'm not. It's my face is on the internet. People could look me up on LinkedIn if they wanted to. I went to UC Berkeley, and got burned out pretty hard from that, and left with a master's degree and felt ashamed of it, which was a silly way to feel. I feel more proud of it now because I recognize that it was an accomplishment to make it that far in the program, even if it wasn't the same outcome as what I thought I was coming in to do.
Yeah. I mean, UC Berkeley, that's a really good school, isn't it?
That's a great school, particularly for physical chemistry.
Jesus.
Yeah.
I didn't go to college.
Oh.
Yeah.
And here you are learning programming anyway.
Yeah, I mean that's what you do when you don't go to college. You learn other things. Physical labor is not my jam, so here it is. This is it.
Yeah, I mean,
Yeah.
I didn't go to college for computer science, and here I am
Yeah.
about to start a
Where are you
job as
from?
a data engineer and
Yeah.
teaching computer science on the internet. So,
Yeah. That's for sure.
so after grad school, I was kind of underemployed in the gig economy and not feeling well in terms of mental health. But I recovered from that little by little. I tried a stint as freelance writing, and while I was doing that, I was networking, talking to anyone who would listen to try to drum up my writing business. But I had an important conversation with a colleague from grad school who pointed out that, hey, I liked the programming we did together in grad school. And I thought to myself, hey, yeah, I liked it too. And then she said, I studied a bunch of MOOCs and went to a boot camp and got a job as a software engineer, and I really like it. And I said, okay, I'm going to try out this programming thing. So I went to a data engineering, excuse me, no, a data science boot camp. But before I went to that, I had some extra time, so I picked up a computer science certificate and then got a job as a data engineer where unfortunately I was out of my depth, and about a year into it I got pretty burned out. That's kind of a recurring theme in my life, is getting burned out of difficult things. But after I left that one, I went to a free Java development bootcamp, which I really recommend this program. It's called Perscolas. And if you have the time to do their training, it's a free training and it's good stuff. Although sometimes I wonder, like, I kind of did 3 boot camps, and I don't know if any one of them would have been enough to get me to where I am right now. I mean, by definition, it took all 3 of them to get me to where I am right now. But anyway, after that one, I got a job at a small ad agency working as a support engineer, but the person I was supporting was a data engineer, so I was kind of doing data engineer work. Let's see. I live in Chicago. I live alone in Chicago with my cat, who you cannot see, but if I switch to the webcam view, hey Sammy, there he is. He's right there. Where's the TV? It will come back in a moment. Yeah, there it is. I like music. If you look on my, well, pardon me, that beep means I have diabetes, type 1 diabetes. So I have an insulin pump that I wear, and it takes care of me pretty well. Although sometimes I eat too much pizza and it can't quite keep up. So that's kind of a bit about myself, and I might even post that in a video if people, so I can refer to it later. It was kind of a good overview.
You could do like some of those one of those commands, like a exclamation point, and then like your
Yeah,
name, and just do like a bio thing in there, or exclamation point bio.
yeah, exclamation
Um,
point bio, that would get it done.
yeah. But it's there. I'm not expecting you to tell me where in Chicago you live, but I was going to say that my girlfriend actually used her. She's from that area. Her family's in like the suburbs. But whenever, like during some of the time we were dating, she was in living in Hyde Park.
Oh, okay. That's a nice
But I
part.
mean, she's not there anymore. Yeah. I moved, or excuse me, I moved like at the beginning of COVID. Like, so we were long distance, and then at the beginning of COVID, I was like, hey, I don't know how long it's gonna be before we get to see each other because of this whole
This whole thing.
pandemic thing. So why don't you just come live with me? And so I went up there. I drove the. I live in the South. I'll put that out there. I live in
Okay.
the South, and I drove 18 hours to go get her. No, it wasn't 18 hours. Sorry, it was 13 hours to go get her,
Still a
and then
lot.
the 13 hours back. Yeah, and yeah, and she's just been living with me ever since. But
That's nice.
the only time I ever saw snow was when wasn't when I went up to visit her in Chicago.
Oh,
Um, yeah,
huh.
it was definitely nice. I remember getting out of the Uber at like 1 in the morning and just jumping straight into the snow.
Oh, that's excellent.
Yeah, it was nice.
I like that.
Um, yeah. But yeah, I understand what you mean about the whole burnout thing. Because honestly, the only thing, like, so I'm not successful enough to where I can, like, I'm not necessarily saying that that's where you're at, but I'm not successful enough at a point where, like, if like I can ever afford to, not be in my job ever again.
Mm-hmm.
Um, and so like I'm just dealing with the burnout, just like, okay, it is what it is, and just kind of like being miserable about it the whole
Yeah.
time.
There
Uh,
is something clarifying about having no other options.
yeah. So that's been fun, and especially since I'm in the management role now. I was just an individual contributor before in like an implementation type role. Um, and once again, it's the South, so I don't get paid all that much. Uh, but I can definitely relate to the burnout, especially like I've been in my role only 6 months,
Mm.
and it's like nonstop, man. Like it just never ends. Um, I'm very fortunate that my biggest problem quit the other day.
Oh, there
It's-
you go.
yeah, yeah. So I'm in much better spirits since then.
That's good. I'm glad to hear that at least.
Yeah. So I'm not like the most positive person in the world, but
Mm-hmm.
what I really can't stand is someone who will complain about good things.
Oh.
They're like, I need more training, give me more training. So I get them more training. They say that training was useless. They say I need more guides, so I give them more guides. It's like this guide is useless. I'm like,
Hmm.
okay,
It gave you what
okay,
you.
you
I
know
kind of
what?
gave you what you wanted, and
Yeah. And like we had several coaching sessions. Nothing was ever their fault. Uh,
hmm.
no matter like anything that was wrong with them was just how they were, and that we're gonna have to deal with it. And me not being like used to being a manager, it was just like, okay, so you say that, but we're gonna work on it anyway. And finally, after her second write up, she was like, I'm gonna leave on my own terms, and so she
Hmm.
did. Best day of my life.
There you go. Problem just walked out the door.
Yeah. And so what's really fun about my role is that it has nothing to do with programming, yet I'm getting to do it.
You found a way.
And yeah, and you know what's lovely is that nobody in my organization knows anything about this kind of stuff, and I just
Hmm.
seem like a fucking magician to them. Sorry if you're not used, if you don't like that kind of language. I didn't even think about asking. They just think I'm a magician.
Thank you
It's
for
great.
recognizing that. Yeah, let's keep it clean on this stream.
Yeah, you got it.
Cool.
Yeah. No, they think I'm a magician, and
I can
I
understand that.
it's great because it's like they think that I'm doing some amazing stuff. It's like, no, listen, like what I'm doing is very, very basic logic. Like I'm not going super deep into things. This is just it's pretty simple. But since they don't know anything beyond sending emails, it's like
Well, yeah,
I'm awesome.
if you're just far enough beyond someone that they can't see where you are, you could be on the moon
Yeah,
as far as they're concerned.
but yeah, that's and I like to tell like anytime like my the other manager in the other location, I keep telling her, it's like you could learn programming too. It's like anybody can learn programming. It's really just taking the time to really understand it, even though it's really intimidating at first.
Yeah.
It's like you hear me, like I don't understand math. I'm no good at math. I didn't graduate college. I didn't even touch college. Never even went.
Hmm.
Um, and yet I'm doing pretty well, I'd say.
Yeah, you seem to be picking up what we've done over today, which is good.
Yeah.
Um, I'm excited for you to see some more of this book because it gets into
Yeah.
some really juicy stuff. Once the
Yeah.
exercises start getting interesting, it's really nice.
Yeah. When we get to loops, that's when I'll be really engaged because I still don't grasp those that well.
Oh, okay, yeah.
Oh, anyway, I will go ahead and get out of your hair because I actually need to get some rest. It's been a long day.
I'll go ahead and let you go.
All right. Farewell. Thanks again for having me on the stream.
You're welcome. Yeah.
Have a good night. Thank you. Goodbye, stream. Goodbye, chat.
Goodbye, Mr. TV screen.
Yes, that's me.
All right, that's off. Let's go to just webcam. Anyone else in the chat want to say any last words for the night? I think I'm going to call the stream pretty soon. Turn the music back up a little bit. It might have gotten too quiet. I'll let the song wind out and then we'll call it. Oh, I didn't know the song was going to be over that soon. I guess that's it. All right, stream, thanks for watching. I'm going to I'm gonna repurpose some of this stuff into YouTube videos. Like I'm gonna have a chunk of it that's just looking at the Think Python book. That'll be a video. And the bit of me talking about myself, that'll be a video. And I'll probably tweet those out once those are up. So if you want to find me on my Twitter, or if you want to find me in the Discord, I'll share them in the Discord as well. And yeah, thanks for watching. We had a pretty solid viewer count for most of tonight. That feels good. We got a follow from Icarus T7. Shout out there. Thank you. And yeah, have a good night.